Before we begin the technique part of this video, it is important to understand a few key ideas. First, the Beer-Lambert law. The Beer-Lambert law shows the relationship between absorbance and the concentration of a solution. The equation for the law is capital A equals A lambda times B times C. Capital A is the measured absorbance, which is found using the spectrophotometer. A lambda is the wavelength-dependent absorptivity coefficient, which is usually given or can be calculated by manipulating the equation. B is the path length, which is the depth of the cuvette, and C is the concentration. Second is, why is it necessary to scan across all wavelengths? One will scan across all wavelengths in order to find the peak wavelength that works for the absorbance for the solutions. Once the peak wavelength is found, that wavelength will be used to find the lambda max. The lambda max is the wavelength where the absorbance is the maximum. Now we are ready to begin the technique part of the video. By this point of the lab, all dilutions should be completed, so the next step is to transfer sufficient but not excess solution to the cuvettes using plastic pipettes. Make sure to create a cuvette for each dilution as well as a blank to zero the machine. Each cuvette should be filled to the faint line as shown. Once each cuvette is prepared, head to room 360 in order to use the spectrophotometer. First, wipe two sides of each cuvette so that there is no debris that could interfere with the readings. Next, place a blank into the spectrophotometer, making sure that the two clean sides are in line with the light source. Close the lid before starting the spectrophotometer. Find the red button that says 0. It is highlighted by the red arrow. Click it, it will zero the machine and negate the effect of the water molecules. The absorbance value circled in the left-hand corner should be at or near 0. When you fail to zero the machine, the absorbance values for all the solutions will be incorrect, giving the wrong numbers to plug into the Beer-Lambert law. Once this is completed, open the spectrophotometer and retrieve the blank. Now that the device is zeroed, you will determine the absorbance of all your samples. The machine only needed to be zeroed once, so the following procedure can be repeated for however many samples you have. First, wipe two sides of the cuvette. Next, place the cuvette in the spectrophotometer with the clean sides in the beam and close the door before scanning. Next, click Read at the top of the screen to begin scanning. Record the absorbance value shown in the top left corner in your notebook. Carefully remove the cuvette and close the door. Complete steps 1 through 6 for all your dilutions. After you collect all your data, you should have a data table that resembles the one on screen. Notice that as concentration decreases, so does absorbance. Once all the data has been collected, head back to the lab and clean up your station. This includes dumping all the solution down the sink, washing your glassware, and wiping down the tables. You are now ready to use the spectrophotometer on your own.